Hey guys, welcome back. In this video, we will be discussing a new topic, that is limits of trigonometric function. So let's start with our first identity. So our first identity is limit x approaches to 0 sine x by x. This is equal to 1. So this is our first identity and we will prove this identity now. So by the expansion of sine x, we know that sine x is equal to x minus x cube by 3 factorial plus x to the power 5 by 5 factorial and so on. Okay, so let's write one more term, that would be x to the power 7 over 7 factorial plus so on. So now we will divide the sine x by x. So that will be sine x by x is equal to 1 minus x square by 3 factorial plus x to the power 4 by 5 factorial minus x to the power 6 by 7 factorial and so on. So now we can easily plug in x equal to 0 so that we can evaluate limit x approaches to 0. So that will be limit x approaches to 0 sine x by x. Let us write it more clearly. That will be sine x by x, and now you can plug in here to evaluate the limit. So x is equal to 0 we can plug in this expansion, so that will be 1 minus x square by 3 factorial plus x4 by 5 factorial minus x to the power 6 by 7 factorial and so on. So now you can easily plug in x equal to 0. So this will be 0, this will be 0, and all other terms will also be 0. Since x is approaching to 0, x square will approach to 0, and all the higher terms will obviously approach to 0. So the answer will be 1. So hence we have proved that limit x approaches to 0 sine x by x is equal to 1. So this is our first identity. Okay guys. So there are some more important results as far as trigonometric functions are concerned for limits. So the other one is limit x approaches to 0 cosine x is equal to 1. So this thing might be clear to you, as it is very intuitive that when x approaches to 0, cos x approaches to 1. So this is the second identity for trigonometric functions in limits. Now the third identity is limit x approaches to 0 tan x. So this is also equal to, this is equal to 0, and we will be proving this now. So as you know that tan x is nothing but sin x by cos x. So we can write it as tan x is equal to sin x by cosine x, right? So we will multiply both the numerator and denominator by x. So this will be x into cos x, and this will be x into sin x. And this thing in, that is limit x approaches to 0 sin x by x, is nothing but 1, right? According to the first identity. So this we can write as 1 into limit x approaches to 0. So by the algebra of limits, we can write it as 1 multiplied by limit x approaches to 0 x by cos x. Right. So when x approaches to 0, this cosine x will approach to 1, and this x will obviously approach to 0. So this will be 1 multiplied by 0 divided by a finite number which is approaching to 1, since cos x will approach to 1 when okay. So this will be nothing but 0. So the result is coming as 0. So the limit x approaches to 0 tan x is nothing but 0. So now we shall use these identities in some examples to be more familiar with how to apply these identities. So let's say we have in our first example, so let's say we have to evaluate limit x approaches to 0 1 minus cos x over x. So this is our example, right? So we're evaluating this. First, we need to be clear that there is an identity 1 minus cos 2x is equal to 2 sine square x. Okay. So if 1 minus cos 2x is equal to 2 sine square x, then 1 minus cos x will be equal to 2 sine square x by 2, as we have just halved the angles here. So let's put this thing in the question. So we will rewrite it as limit x approaches to 0, 2 sine square x by 2 over x. So now what are we going to do next? So this thing is sine square x by 2, right? So which identity can be used from the previous used identities? Just try to recall. So I think you might be able to recall that we can make use of the identity limit x approaches to 0, sine x by x is 1, right? So we will make use of the identity. So let's take this thing squared thing into consideration. So let us try to separate it in the form of sine x by x. This is sine x by 2 over x by 2, and this thing is whole squared. So x by 2 here, we multiply in the numerator and the denominator as well, right? And now look at this thing. Limit x approaches to 0, sine x by 2 over x by 2 will approach to 1, as you can relate from the first identity. So we can make this thing as 1, and this whole thing will become limit x approaches to 0, 2 by x multiplied by 1 multiplied by x square by 4, since this was x by 2 whole square. So this is coming as limit x approaches to 0, x by 2, and now we can plug in x equal to 0 in this. So this will come as 0. So the answer is 0, right? So hope you guys might have understood the basics of how to deal with limits in trigonometric functions. And we will be covering the remaining concepts in upcoming videos. This is it for this video. Bye bye.